So again, good morning, good afternoon, and good evening to all. We are, well, several hundreds of people from all over the world connected right now. So welcome to our Dark and Quiet Skies workshop for science and society. We're going to be together for the whole week. And today we're going to talk about dark sky oasis. My name is Nathalie Ricard. I work for the Office of Outer Space Affairs in the United Nations in Vienna, in Austria. And before we get started, I just wanted to remember everybody that we do have reports available for you to review. So if we could please move to the slides showing how to access them. You should have received this per email. You can download the reports. And then once you've seen the presentation, if you have comments on our recommendation, please send us your comments in writing at this address. If for whatever reason you haven't received this detail, please email UNOSA events and we will send you this detail per email again. So I now have the pleasure of introducing Simonetta Di Pippo. She's the director of the United Nations Office for Outer Space Affairs, and she's going to give us a few words of welcome.
Distinguished speakers, dear participants, colleagues and friends, good morning, good afternoon, and good evening. On behalf of the United Nations Office for Outer Space Affairs, please allow me to welcome you to the Dark and Quiet Skies workshop. Despite not having the pleasure of seeing you all in person, I'm delighted that so many of you have joined us today. It is truly impressive to see great interest in the topic, and to make my point, let me underline that we received over 800 registrations from almost 80 countries. And the diversity of the audience is also great news. We have participants from academia, from space agencies, and from the commercial space sector. The event stands as a great example of successful business continuity being delivered by the Office for Outer Space Affairs during the ongoing pandemic. Through adaptation of our programmatic activities and the strength of our partnerships network, we are delivering continued engagement with the international space community across the full breadth of our work. The Dark and Quiet Skies workshop is a joint initiative of the United Nations, Spain, and the International Astronomical Union, and technically managed and supported by the National Optical Infrared Astronomy Research Lab of the United States. I have the honor, together with Constance Walker, to co-chair the Scientific Organizing Committee of this initiative, and we are looking forward to 5 days of presentations by our outstanding speakers. The United Nations, an organization with a global reach, brings together 193 countries and strives to facilitate cooperation between the organization and its member states, among countries themselves, and with external stakeholders. The unique convening power of the UN has been crucial to address a wide range of issues in the 75 years of its existence. And it is at this point in history that the organization is becoming more relevant than ever. The challenges we face, be it climate emergency, the COVID-19 pandemic, conflicts, or matters of space safety, security, and sustainability, will not be solved by any one country. We are in this together, and it is the duty of the UN to serve as unifying force in addressing issues that concern all of humanity. The space sector can indeed serve as a sort of a role model for global cooperation. Since the 50s, countries have come together through the UN in seeking common grounds on governing space activities in outer space with considerable success. As the only UN entity dedicated to space, UNOSA works across the legal, policy, scientific, and technical aspects of making successful international cooperation in space a reality. The momentum behind the elevation of space matters on the UN agenda is really strong. At the multilateral level, the recent adoption of the long-term sustainability guidelines, considerable growth of the UN Committee on the Peaceful Uses of Outer Space, and the global attendance to UNOSA events underline the continued appetite for multilateral diplomacy and friendly relations in this frontier field. The Dark and Quiet Skies workshop was mandated under the UN, showing full commitment of the member states, and UNUSA hence welcomed the request to organize it on the general topic of light pollution together with the International Astronomical Union, and welcomed the offer of the government of Spain to host such gathering. We count on this event to push this item forward from a political perspective in the agenda of our member states. Ladies and gentlemen, the rapid growth in the number of satellites launched, especially in low Earth orbit, affects observations from ground-based astronomical observatories. We need to find a common understanding. On the one hand side, constellations can help provide global internet coverage and bring the remaining 3 billion people online, a giant leap forward in connecting the globe. But at the same time, we must protect science and astronomy. We must engineer a step change in discussions at the international level among all relevant actors. And the Dark and Quiet Skies workshop should be exactly that, proposing recommendations which can eventually be acted upon either by local governments or agreed to at the international level. The draft recommendations will be presented for your consideration and updated based on the comments received and eventually presented in February 2021 at the Scientific and Technical Subcommittee of COPUS. Afterwards, the recommendations will be consolidated at the Dark and Quiet Skies Conference in Spain in April 2021. UNUSA always stands ready to support activities of member states in seeking solutions to issues in space and on Earth by bringing the community together through partnerships, networking, and cooperation. As I said before, it is not time for unilateral actions when dealing with challenges that we collectively face. UNUSA is doing everything possible to make space benefits more accessible to everyone in this key moment for the planet, when we must build back better. But at the same time, we call for upholding the highest standards of responsibility in space activities so that we can protect not only safety, security, and sustainability in space, but also space science on Earth. It is precisely through this structured engagement with the global space community that we can make a real difference in the world and the skies above. So thank you very much.
So, good afternoon, good evening, good morning, everybody. My name is Kathy Neild, and I'm the General Secretary of the International Commission on Illumination, based in Vienna, Austria. And I'm pleased to be the moderator of this first day of the workshop on Dark and Quiet Skies for Science and Society. Today, the focus is on the material prepared on the topic of dark sky oases. But first of all, a little housekeeping. Today, you are muted and your video cannot be turned on. I hope we have your understanding on the reasons for that, with over 800 people here today. But if you have a question, please just use the chat at any time to send a question. Keep your questions short, and remember that the questions will be prioritized and only to the recommendations of the working group, and only a subset of questions will be taken care of at today's meeting. So, this particular workshop, the particular document on dark sky oases, has been prepared by a working group of 9 experts led by Professor John Earnshaw of the University of Canterbury, New Zealand, and Dr. Antonio Varela of the IAC Canary Islands. Professor Earnshaw and Dr. Varela are here today to present some of this material, along with some other members of the working group. Dr. John Barentine from the International Dark Sky Association, Dr. Kostis Borousis of the Technical University of Athens and CIE Division 4 will also attend to this material today. Other people from the working group, who you can see their pictures on the screen here, are Pedro Sanhueza from Chile, Casiana Munoz Tuñón from Spain, Zohair Ben Khaldun from Morocco, Steve Lau from China, who unfortunately is not here today, and myself. So with that little brief introduction, I'm going to open the floor to Professor Earnshaw, who's going to give the first presentation on this material. and that his presentation will be on an introduction to sky glow from artificial light at night. So John, over to you.
Okay, so thank you very much for the introduction, Kathy. We're going to a workshop about light pollution, and light pollution is actually the sum of obtrusive light, artificial light at night. And it's there are three aspects to light pollution. One is glare, which is light shining straight into an observer's eyes and partially blinding them. There's also light trespass, or sometimes called spill light, where lights are shining on places which are not intended to be illuminated. And that's particularly has a bad effect if light is shining into bedroom windows, for example. And then light pollution also causes sky glow. Now, sky glow is when the night sky is brighter as a result of artificial light at night. And that prevents us from seeing the stars so easily and affects astronomy, and including amateur astronomers and professional research. So sky glow is caused by light going up into the air and being scattered by the air molecules, or by small particles called aerosols in the Earth's atmosphere. Can we see the next slide? And on this slide, this is a picture taken from the International Space Station a few years ago. And you can see the Earth's atmosphere from a tangential angle here. So you're looking through a large thickness of atmosphere. And we see that the sky is quite bright. This is in fact a natural airglow. It's not mainly not sky glow caused by light pollution. So the Earth's atmosphere is shining all the time and producing this airglow. Now, if there's artificial light at night contributing also to the sky brightness, this is actually one of the big environmental problems facing humanity at the present time. Personally, I would put light pollution on a par with other big environmental issues like global warming from greenhouse gases and plastic waste in the oceans. But rather surprisingly, the environmental problem of sky glow is one which we could easily solve just by promoting good lighting. So on the next slide, we can see why we should have good lighting. We know that light pollution probably has an adverse effect on human health. That's the first reason. And we know that artificial light at night, light pollution, can adversely affect the environment, and many species are being driven to extinction by light pollution. And light pollution also wastes a lot of electricity. In fact, billions of dollars of electrical power is wasted every year by light going up into the sky. Now, the main reason for this workshop is to discuss why artificial light at night, called ALAN, which brightens the sky, and it makes it more difficult to see the stars. So that's the main topic we'll be talking about. But also, if we have really good street lighting, actually that promotes greater public safety. Properly installed lights which don't cause glare, for example, can increase safety. So we have to install our street lights with great care to ensure that. There's one other economic aspect of really good lighting, and that is good lighting promotes dark skies, and dark skies allow people to admire the beauty of the night sky, a starry night sky. And there's a rapidly growing aspect to this, which is astro-tourism. And now many thousands of people, at least until last year, before the pandemic, are traveling to really dark locations to admire the beauty of the night sky. So what we want to be able to do is actually measure the brightness of the night sky to see how bad the effects of light pollution are. The next slide, please. This points out that there was an amateur astronomer in the United States called John Bortle, and about 20 years ago, he introduced this scale for specifying the brightness of the night sky as a result of light pollution. And he had a scale of 9 classes. Class 1 is for the very darkest sites in the world, and class 9 is for the most polluted sites in the biggest cities, where the sky is so bright at night you can hardly see any stars at all. So the Bortle classes are based on what are the faintest stars just visible to the naked eye. Now, if you're on a really dark site, we can see down to magnitude about 6 or 6.5. Astronomers use a scale of magnitudes. The very brightest stars in the sky are magnitudes about 0, and the faintest 6.5 on the magnitude scale if the sky is really dark without light pollution. But if there is light pollution, perhaps the faintest stars are only magnitude 4 or even 3, which is a lot brighter than in a dark site. So let's look at the next slide, and we will see a diagram showing the Bortle scale. Well, the writing here, I'm sorry, is a little bit small, but the magnitude of the stars is shown in the second column from the end, and you can see down to about magnitude 6 or 6.5, which is for the darkest sites. But if the limiting magnitude is brighter than that, then the number of stars rapidly decreases. And the very last column on this nomogram shows how many stars roughly are visible in a hemisphere of the sky. And in the dark sites, it's probably about 3,500 stars can be seen at any one time. But in the very brightest sites and big cities, it may only be half a dozen stars are visible. So that's the Bortle scale for measuring sky brightness. But we want a more quantitative way of doing that, and astronomers often use the units of magnitudes per square arc second. Now, the magnitude scale used by astronomers is not very intuitive. It's what we call an inverse logarithmic scale, and 2.5 magnitudes is a factor of 10. And what we've got to imagine is a very tiny area of sky, a square arc second, and imagine that the light from a faint star is spread over that square arc second, and that would be an indicator of the brightness of the night sky in magnitudes per square arc second. Well, if you have no light pollution at all, the night sky would be about magnitude 21.8 magnitudes per square arc second for the brightness of the night sky. And that's Bortle class 1, by the way. But in the most polluted sites on Earth and big cities, the night sky might just be magnitude, say, 16 or perhaps 18. That would be Bortle class 8 or 9, with only a few dozen stars visible, if that. So that's the one convenient way of specifying the brightness of the night sky in magnitudes per square arc second. But there are more photometric ways of specifying brightness, and it's quite useful to have a unit such that the brighter is the sky, there are more, a larger number, which is not the case with magnitudes. And one unit which is sometimes used is the so-called S10 unit for measuring the brightness of the night sky. Now, in the S10 unit, if there is absolutely no light pollution, just the natural air glow, there's about 145 S10 units. So the S10 unit is the equivalent amount of light from a certain number of 10th magnitude stars, which are fainter than the naked eye limit, of course, spread over uniformly over a square arc minute. An arc minute is a 60th of a degree, of course. So we can imagine so many 10th magnitude stars, their light spread over an arc minute, and that would be if one such star would be one S10 unit. So an unpolluted night sky is about 145 S10 units. A very heavily polluted sky in big cities where the limiting magnitude is, where it's about 16.7 magnitudes per square arc second, that's equivalent to about 27,000 S10. It's worth noting that these are visual magnitudes, sometimes called yellow magnitudes. They are the magnitudes to which those are the wavelengths of light to which our eyes are the most sensitive, namely yellow light. Let's look at the next slide, and here we discuss a more photometric international system units, which are normally recommended by physicists for measuring the brightness of the night sky. And this international system unit is called the millicandela per square meter. So we've got to imagine the hemisphere of the night sky to be imagined as a great big hemispherical surface. Let's take 1 square meter of that surface in the sky, and a millicandela tells you how much light in a solid angle is coming from that square meter. So the definition is a little bit technical, but the natural air glow without light pollution is about a quarter of a millicandela per square meter, and anything over 1 millicandela per square meter would be quite significantly light polluted. And once again, the candela is based on the visual photopic passband to which our eyes are most sensitive during daytime. And that passband peaks in the yellow at 555 nanometers wavelength. And it's not very sensitive at all to blue lights and below 500 nanometers. So this today's workshop is about dark sky oases. In the next slide, we discuss what is a dark sky oasis. And a dark sky oasis is a place with a dark sky which is protected by some kind of lighting policy, or in legal terms, by a lighting ordinance, which limits the amount of light going up, artificial light going up into the night sky. So dark sky oasis, or sometimes called a dark sky place, will probably have controls on street lighting, controls on sports facilities being illuminated at night. And if there are commercial facilities such as factory yards or ports or whatever in that location, there'll probably be controls on the lighting there, making sure they shine downwards, and probably flood lighting of buildings in a dark sky oasis will not be permitted. So there are a number of dark sky places recognized throughout the world, and there are 2 main international agencies which recognize dark sky places. Can we look at the next slide? Thank you. So here are the main accreditation agencies. The International Dark Sky Association has headquarters in Tucson, Arizona, and we're going to discuss these organizations in more detail with speakers who will follow me. And the other one is the Starlight Foundation, based in Tenerife in the Canary Islands and Spain. There are also some national agencies, and probably the most prominent of the national agencies is the Royal Astronomical Society of Canada. They recognize dark sky places, but just in Canada. So by mid-2020, there were 223 dark sky places in 27 countries, covering over 20 million hectares of area where the dark sky is protected. And that number was a few months ago, and probably every year there are several more dark sky places are added to the list of accredited places. So I suspect the number today is probably more like 240 or 50. So on the next slide, we see that the IUCN, which is the International Union for the Conservation of Nature, they have classified dark sky places into 6 classes, and they have a dark skies advisory group, and I'm a member of that group. So here is the IUCN classification of dark sky places. They don't do accreditation, they just keep a catalogue of all these dark sky places around the world. The IUCN Class 1 are those with astronomical observatories, and there are 15 which are also with IDA, Dark Sky Association, or Starlight Foundation accreditation. Then there are Class 2 are dark sky parks, which are often in national parks and protected areas, so people can go to these and admire the starry night sky. Then there are heritage sites, for example, places like Stonehenge, which have an astronomical connection. There are 9 of those in the world, which are dark sky places with protection. Then there are outreach sites, generally a public observatory where the public can go and be shown the night sky. Then there are dark sky reserves, which are a mixture of rural and natural area jurisdictions, and those are IUCN Class 5. And finally, we have dark sky communities, which are more urban, perhaps a whole town or a village could be a dark sky community, or a rural area right on the edge of a town, and there are 39 of those in the world. So there are the dark sky places already with accreditation. 223 are recognized in the world at the present time. Now, light pollution is a major problem in many places. Let's look at the next slide. And Fabio Falchi in Italy produced this very important atlas called the New World Atlas of, no, that's the slide I want. He produced, with his colleagues, produced this New World Atlas. And this is an atlas showing how bright is the sky in a global map of the whole world. And it's based on satellite observations of light going up into space. That's wasted light, of course. And if you can measure the brightness of the light going up into space, then with computer modeling based on light scattering in the atmosphere, you can predict how much of the light's going into space. In fact, some of it will be scattered back down again. So you can predict each location on Earth what the night sky brightness would be. And that's a very useful way of rather quickly getting night sky brightness figures for every location on Earth. And the resolution of the World Atlas is just a few kilometers, so every town and city in the whole world has data for the night sky brightness from Falchi's New World Atlas. So it's very important. So let's look at the next slide, and some of the predictions of the New World Atlas are given here. And it's rather shocking that 80% of the population in the world, because a lot of people live in cities, 80% of the total population of the world live under light polluted skies. That means their view of the stars is impaired. However, in some places in the world, it's much worse. In the United States, 99% of the population live under polluted skies, so they can't see a really dark sky and admire the Milky Way. And in Europe, much of Europe, that's also the case. The Milky Way is a view of our galaxy seen from inside the galaxy, and the galaxy is a disk, and the Milky Way is the appearance of that disk as seen from the Earth. But about 1/3 of humanity, also 60% of Europeans and 80% of North Americans, are simply unable to see the Milky Way because the Earth is so bright. And 88% of Europe, nearly half of the US experience light polluted nights. Let's look at the next slide. There is a map from Fabio Falchi's New World Atlas, and the yellow to red areas, you can see the eastern half of North America, much of Europe, eastern part of China, a lot of India, and even in the Middle East, the sky is very bright. The southern hemisphere is much better off. So I live in New Zealand, which you can hardly see in the bottom right corner, and fortunately our skies are fairly dark. So how many stars can you see if you live in a polluted place? Let's look at the next slide. Next slide, please. Here is the first column is the visual magnitude. And remember, you can see normally in a dark place, perhaps to magnitude 6, perhaps 6.5. Magnitude 7 or 8 are too faint to see without binoculars. But there is the visual magnitude, measure of the brightness of stars. Remember, each magnitude is about 2.5 times fainter as you go down that column. Second column is just a range of magnitudes. How many stars are there in a full hemisphere? Of course, we can't see the lower hemisphere from any location. There's the number of stars, roughly, in that full hemisphere. The next column is the cumulative total, adding up those numbers in each range. But of course, we can only see one hemisphere, not a full sphere, and very close to the horizon, that's, the stars, they're pretty hard to see. So I've taken arbitrarily about 10 degrees above the horizon is where you can best see the stars, from 10 degrees above the horizon to the zenith. And if, say, you can see to magnitude 6, which is the case for a fairly dark place, you can see about 3,500 stars. But you can see that if the limiting magnitude is, say, magnitude 1, which would be in one of the mega cities of the Northern Hemisphere, the number of stars will be in single figures. And that is a disaster for astronomy. So I'm going to come back and talk a little bit later, but now I'm going to pass on to my colleague, John Barentine from the International Dark Sky Association. John, please come in.
Thank you, John. I will now speak to you about two subjects. First, the ways which we classify and protect dark sky oases, and second, how my organization engages in this work around the world. In order to promote the active conservation of natural nighttime darkness in dark sky oases, we must first devise a way of describing them. We do this in two ways: by considering the status of the resource using the quality of the night sky as a proxy, and then by looking at the ways that land use affects integrity of the resource. Combining our knowledge about these two enables us to create a management plan for essentially any kind of dark sky oasis. The first characteristics that we evaluate is the quality of the night sky, which is inferred from its surface brightness. As John described previously, there are both natural and artificial sources of light in the night sky, whose sum gives us the total brightness that we take as an indicator of its quality relative to an assumed natural state. For the moment, we consider only those natural sources of light as suggested here on the left. Some of that light originates in the Earth's atmosphere through various physical and chemical processes. John showed a slide about the Airglow, which is one of those components. The rest of that light originates beyond the atmosphere and is fairly described as astronomical in nature. It is the total of this cosmic light and atmospheric light that establishes a kind of floor beneath which the brightness of the night sky cannot fall. We refer to this minimum natural night sky brightness as a kind of unit, which is indicated over there as a night sky unit, or NSU. And then we measure the anthropogenic contribution to sky brightness in multiples of this unit. This is suggested by the chart at right, which is adapted from the nomogram of different night sky brightness values that John showed you earlier. In this version, I've clearly indicated the range of night sky units in the logarithmic scale on the left, which ranges from 1 to 1,000, so 3 orders of magnitude. As a point of comparison, the scale to the right shows the same brightnesses in SI units of candela per square meter. The labeled boxes to the right of that, of the scale, suggest some divisions in the night sky brightness corresponding to settings with different relative amounts of anthropogenic light. So this shows that the night sky in cities can be many hundreds of times brighter than a natural night sky that is free from sky glow. To the extent that the brightness of the night sky in a natural area determines the illuminance at ground level, it's a first order estimate for the biological exposure to light at night. But this scheme gives preference to the human visual system and the perception of the night sky by humans because we use photometric rather than radiometric units. So just be advised that it is by no means ideal for the purpose of evaluating the ecological impacts of artificial light at night. Next slide, please. The second way by which we classify dark sky oases is by virtue of ways in which their land uses are typically described. We further distinguish 2 broad types of land use for this purpose. One identifies the built environment inhabited by humans. There's an expectation of artificial light at night in many instances in the built environment in order to provide for distinctly human needs. The other broad land use type is protected lands like national parks and nature reserves. These places are often public lands, but sometimes they are privately owned and managed. In protected places, we expect typically far less artificial light at night due to generally lower rates of development and a greater emphasis on natural resource conservation. So it is fair to say that dark sky oases are not simply wilderness areas with no human presence. They are, in fact, instances where the built environment exists within many dark sky oases, and international recognition programs encourage populated places to be good influences on protecting dark sky oases, whether they are near or far. Similarly, local instances of nighttime darkness exist in the built environment of cities, and they often play an important role in the conservation of urban wildlife. Next slide, please. Next slide. Thank you. John previously showed you these 6 types of dark sky oasis that are recognized by the International Union for the Conservation of Nature, or the IUCN. This table lists the IUCN types, and we give suggested upper limits for the brightness of the night sky in each type of place according to the night sky unit that I just described. Because of the variability of the night sky background due mainly to fluctuations of the brightness of atmospheric light sources, these thresholds are really only advisory, and we do not intend them to suggest hard limits that could be tied to laws or regulations. We merely offer them as a kind of rule of thumb for quickly differentiating the different IUCN classes by their night sky quality. In the 3 columns that follow are shown the designation category names for the 3 major organizations offering accreditation for dark sky oases. Differences in the priorities of the different programs mean that there is not always perfect correspondence between the categories, and not all of the programs recognize all of the IUCN types. The purpose of the table is to show that there are significant opportunities available for independent third-party certification of a wide variety of dark sky oases, and for each of these, a best management practice exists. Next slide, please. The point of these programs is to support voluntary efforts at the sites to protect the quality of the nighttime environment to the greatest possible extent in order to preserve its integrity and support protection of dark night skies, even in a world that grows brighter every year. There are 3 elements of these programs. First, they encourage sites to identify natural nighttime darkness as a significant natural resource, proceeding from the conservation ethos that to conserve a resource, it must first be valued, and to be valued, it must be understood. This involves characterizing the existing darkness in an area relative to its natural state, as well as identifying what threatens it. The second element involves managing the resource. Best practices result from years of research and experience and are often tied to achieving the missions of the entities tasked with managing these places. Threats to natural nighttime darkness can be internal to a location or external in nature. Often, dark sky oases have little influence over the distant threats, but they typically have full control over how outdoor lighting is used locally. Their task is then to ensure that artificial light is used judiciously and intentionally, making that use a routine aspect of master resource management planning. Finally, recognition programs incentivize the continued application of these practices. An important incentive is in the form of tourism that responsibly caters to tourist demand while ensuring that the very presence of tourists and the infrastructure that supports their visits does not degrade the resource they're coming from around the world to see firsthand. This can be a form of sustainable rural economic development that distinctly benefits locals and encourages them to keep up the good work inherent in receiving a dark sky designation. Next slide, please. Next, I will briefly introduce my organization, the International Dark Sky Association, or IDA. Based in Tucson, Arizona, it is the world's premier non-governmental organization dedicated to the issue of light pollution. Our mission is to preserve and protect the nighttime environment and our heritage of dark skies through environmentally responsible outdoor lighting. At IDA, we believe that dark skies can comfortably coexist alongside the many uses that people make of the nighttime environment. We must understand the underlying causes and mechanisms of light pollution, as well as the solutions to the problem that it poses, and then communicate that information effectively to the global public. Our advocates work with policymakers and outdoor lighting equipment manufacturers to promote good lighting design and proper regulation of outdoor lighting. Our strategy is not to solve the problem of light pollution by turning the world's lights off. Rather, it is to make the world's lights better. Next slide, please. IDA's flagship program is called International Dark Sky Places. Almost 20 years after its first designation was announced, the program has certified more than 150 places in 20 countries on 6 continents. These places add up to a land area of a little over 100,000 square kilometers, which is roughly the size of the country of Iceland. The foundational idea of the program is that designation should not be simply rewarding places for being dark, but rather specifically for actions undertaken to either maintain natural darkness where it still exists, or to actively promote its rehabilitation where it is under threat or has been lost. International Dark Sky Places show that this approach is possible on landscape scales, and that the conservation best practices embodied by designated places are equally applicable in many different geographies and legal jurisdictions. Designations are made on the basis of written applications following a set of guidelines published on the IDA website and subject to peer review. Achieving successful designation is not the end of the process, but rather the beginning of a relationship between the location and IDA. The family of International Dark Sky Places shares among its members knowledge and resources to help them all maintain high standards for dark sky protections. And now I will hand the presentation over to Antonia Varela, who will tell you about how the Starlight Foundation also works to protect the night.
Thank you, John. Well, Starlight officially worked in the first International Starlight Conference held in La Palma Islands and promoted by the Institute of Astrophysics of Canary Islands in 2007, in which representatives of UNESCO Main and Biosphere Program, United Nations World Tourist Organization, International Astronomical Union, European Union, many commissions of United Nations and other organizations released the Starlight Declaration in defense of the night sky and the right of the starlight. Next slide, please. With the objective to spread the importance of the starry sky among the population, considering an outstanding universal cultural, scientific, environmental, biodiversity, well-being, and also a driver of sustainable economy through the astro-tourism. The Starlight Foundation is a non-profit organization and the body in charge of this initiative, providing human resources and means for its development and promotion. Our main goals are the protection of the night sky from light pollution and sky glow, the adoption of smart lighting and innovation and the consequent energy and economic saving, the cultural dissemination of the astronomy, and the promotion of astro-tourism to enhance people to appreciate the starry sky in dark and quiet sky places. Next slide, please. In order to do that, the Starlight Foundation has created the International Certification System that seeks to guarantee the capacity to enjoy the view of the stars and to discover the associated scientific, cultural, natural, and scenic values. There are two main categories. The Starlight Reserve concept was established in the UNESCO World Heritage Center in Paris in 2007, and criteria were established in London and Quebec in two seminars 1 year later. It's a protected natural area where there exists a commitment to protect the quality of the night sky and to preserve the cultural, scientific, and the natural landscape values. Today they cover different categories, as John has mentioned, which are the Starlight Heritage Sites, the astronomical sites, landscapes that include national, regional parks, the Starlight Oasis, human habitats or biosphere reserves, and the mixed Starlight sites. And the Starlight destinations or visitable places characterized by excellent quality of the contemplation of the starry sky and the practice of tourist activities based on this natural resource. The Starlight Tourist Certification concept, created in the World Tourist Organization Center in Madrid in 2010, which has the aim of fostering worldwide the improvement of the quality of tourist experience and the protection of the night sky in the Starlight destinations, bringing for the first time science and tourists together. This certification is the only existing one in astro-tourism in the world. Next slide, please. The excellent sky quality is the sine qua non condition to be accredited as Starlight. There is a large list of parameters that determine the sky quality of a site, not only the sky brightness, that is very, very important. In the sky team of the Institute of Astrophysics of Canary Islands, we have been long time working, more than 30 years, in providing the list of these parameters. And we have proposed from this team the astronomical parameters for the Starlight certification. The different parameters are the cloudiness, related with the useful time, the sky brightness, but also the scene, which is the blurring and image motion of the astronomical images that is very appreciated by the astronomer, and the transparency that is related with the quality of the air and the atmospheric pollution. These measurements can be obtained by using in situ instrument and techniques, and also retrieving data from satellite. These instruments are indicated in the last column of the table. And here, however, we are open to adopt the new technologies. From this analysis, a zooming of the territory is obtaining, as you can see, right hand right, is obtaining this zooming is crucial for future lighting projects. At the end of this study, to be organized by the Starlight certification, both astronomical and astro-tourist presential audits are performed by external experts. Next slide, please. The Starlight Foundation has also created other accreditation to those private or public spaces or places that meet very good sky conditions, which are favorable to the contemplation of the stars. Among these accreditations, there are rural houses and hotels, inns, camps, stellar parks, wilderness, roads, activities, or even cultural monuments. Next slide, please. Nowadays, there is a network of 45 Starlight reserves and destinations, including national and regional parks, heritage sites, biosphere reserves, and more than 70 rural houses and hotels, and other modalities, both in Spain, but in other countries such as in Chile, Canada, Portugal, Italy, France, Colombia, etc., covering more than 75,000 square kilometers. There is also more than 500 Starlight declaration adhesions, we can say that the selectivity of protected sites for astro-tourism is more and more requested by increasingly demanding visitors. Next slide, please. The fragile light of a star became a new driver for sustainable tourism in unpolluted rural communities and natural areas. Astro-tourism is an activity of travelers wishing to use the natural resource of well-kept night sky for astronomy related leisure acknowledge the peculiarities of each place, gea, flora, fauna, landscape, lodgements, path, and star viewpoints, together with the interest of the visitors, makes necessary the specific training of people. These are the Starlight guides and monitors who are specialized and guided groups during the night and the day, so that the visitors, in addition to enjoying nature, may enrich through dissemination the knowledge of the universe. There are more than 500 guides and Starlight monitors, audits, teachers for more than 15 nationalities. And the Starlight Foundation participates also in programs for teachers and students in schools, women in astronomy, recovery of empty buildings for exhibitions, workshops, and inclusive astro-tourism. Next slide, please. In this conference held in La Palma, it was commemorated the 10th anniversary of the Starlight Declaration in defense of the night sky and the right of the star. And the signing and other institutions adopted resolutions and made the call facing the future. It was acknowledged the full validity of the Starlight Declaration signed in La Palma Islands in 2007, and the whole population, the local communities and the governments were encouraged to adopt their principles and guidelines. Next slide, please. The Tourism of the Stars, or Astro-tourism, is an emerging and innovative segment of the tourism industry. A quality job creator, a new space creator, is a powerful tool to disseminate the astronomy for reevaluation of the natural, cultural, historical, environmental, and ethnographic heritage of the people, and also foster the sky protection and preservation. There are many international publications release and promote stargazing in dark sky oases. The annual growth of the number of visitors reaches up to the 350%. Also, the Starlight Foundation was one of the winners in the Feature Next 2020 challenge among more than 250 innovative sustainable tourist projects of more than 50 countries. Next slide is our colleague, Kostis Bourousis from CIE, Wilford.
Okay, thank you, Antonio. So I will talk about the evolution of light sources and luminaires. So if we compare the early days and today, there was a long way in technological innovations and chase for energy efficiency. During the early years, humans were using torches and other fire-driven systems for outdoor lighting. And if we go fast forward to today, the world is rapidly changing to the LED lighting. But the long way between these two technologies is filled with various lamp technologies, as you may see. We have using or still use different type of lamps for illumination of our streets, parks, and outdoor places. We can distinguish three major group of lamp technologies: filament, fluorescent, and high intensity discharge lamps. They varied from as low as 5 or 7 lumen per watt up to 170 lumen per watt, using different type of elements inside in order to produce the visible radiation that we have. With the LED now, we have entered the solid state era using advanced technology and high energy efficiency. Most of these lamp types you see are still in use today for outdoor lighting, while certain have been phased out in certain regions around the globe. Next slide, please. As mentioned, each light source produces light with different materials and technology. The result is a variety of emitted spectrum. On the left side, you can see the emitted spectrum for the major type of conventional light sources. So you can see that they emit in specific bands or specific wavelengths. take as an example the low pressure sodium, the incandescent, the mercury vapor, and compare them to the daylight and see how different they behave. On the other hand, we have LED that emits a wider band of the visible spectrum, while their balance in emitted power per wavelength depends on the color temperature. We want to focus on the blue region, which is, as mentioned, has a negative impact in sky glow and the bioenvironment. Many of the conventional light sources are emitted in blue, but in LEDs, this percentage is much higher, especially for models with higher color temperature. We can see the differences between 3000, for example, and 6000 kelvins, but on the other hand, there is a special category of LED which is called amber LED, and this specific LED emits almost no blue light. So despite which kind of LED the new technology is using, we need to consider the actual emitted light from the luminaires. So in this graph on the right, if you can press a click, please, you can see a measurement of 50 different LED luminaires with nominal color temperatures from 3000 to 6000 kelvins. So there is a lot of variation between them, and this is also a nice example that just the CCT number tells few things about the emitted spectrum. Next slide, please. Now let's investigate what is happening with the luminaires and how they've been evolved during the years. Initially, luminaires function as housings for the lighting sources without any kind of control on lighting distribution. Therefore, light can go everywhere around without any control, any restriction, or any kind of distribution prediction. Later, street luminaires distributed mainly towards the road using special optics, using dedicated housing, but they also emitted upwards. So it was a main issue of early street luminaires. So if we have the more modern, let's say, street luminaires with conventional light sources, they mostly use cutoff design and better optics, while they have made potentially additional accessories to reduce spill light. Again, there are a lot of low quality luminaires around which produce a lot of spill light. Today, we have LED street luminaires, which are based on the design of the lenses and the reflectors, and they can achieve maximum control of lighting distribution, and they can easily focus to the area under illumination. We therefore moved from just simple lamp holders to some complex lighting distribution devices. So next slide, please. Let's see how LEDs transform the luminaire technology and luminaire industry in general and lighting controls. They actually increase the efficiency compared to traditional light sources, except from low pressure sodium, of course. There are small lighting sources compared to the traditional ones, and these can be used efficiently if we have lens, diffuser, or reflector designs that can distribute the light where we want it to be emitted. LED LEDs also permit full control of the luminous flux, like dimming over time or via adaptive system. In addition, they can be equipped with different color temperatures. So we may have, for example, tunable white luminaires that actually tends to be a standard in indoor and outdoor applications. With the LED luminaires, there is a huge energy potential, as we know, compared to the existing lighting installations. Next slide, please. But there is actually a bad reputation, and something actually led to have the LEDs as a bad choice. First of all, there was a big need for massive renovation the recent years, and the main concern was just the energy saving. This was also combined with the huge number of low quality Me-Too products that anyone could find very easily and cheap in the market. Lighting design in that case was actually very basic or not at all. On the other hand, there was a noticeable difference between the efficiency of, for example, 3000 Kelvin and 5000 Kelvin, which actually led to select cool white LEDs. So we have a lot of LEDs around with very blue light emitted. Finally, in terms of commissioning, validation measurements, or monitoring of lighting levels, that was actually a luxury option in this renovation project. Therefore, we had a lot of complaints about blue lights and glare situation, as mentioned from by the previous speakers. Next slide, please. Here we have some remarks about the new technology. So its light source is not an a priori source of light pollution, since obtrusive light and sky glow is a combined effect of light sources and luminaires together. We've moved from a traditional light sources, which offered actually limited option in produced lumens and wattages and restrictions in optics, to a technology that offers full flexibility in both lighting distribution and emitting spectrum. So the synergy between all these new technologies combined with appropriate lighting control system can drastically reduce the adverse effect of ALAN and preserve dark sky oasis. Thank you for your attention, and I will hand over again to Antonio.
Thank you, Kostis. Okay, we are going to emphasize the value of dark sky oasis. The dark sky oasis must be pioneer's model to foster implementations of environmental friendly and sustainable lighting solutions. They should adopt effective measures to control and eradicate light pollutions in defense of the integrity of their cultural and natural associated values, fostering regulations of mass lighting innovation and the consequent safe energy and economic savings. Next slide, please. Quite important is also the scientific value. The present-day technical and scientific requirements restrict reachable areas to very specific and limited locations, offering good conditions for the development of astronomy and for optical and infrared astronomy in particular. There are only a few places on the planet where we find these unique combinations of environmental and natural circumstances, well-conserved spaces with very little alteration to natural starlight. These exceptional sites, including their natural components, can be considered as landscape of science and knowledge, having identified the best locations for astronomical observation throughout the planet. It's critically important to try to conserve and protect them. The case of Hawaii, the Canary Islands, Namibia, or northern Chile, or an example of discrete sites that within this context have outstanding universal significance. Next, please. The close and perpetual interaction between astronomy and its role within human culture is a vital element of our outstanding universal value of the dark sky. There is a lengthy human history and prehistory terms of astronomical themes in art and architecture. There are places of mystery and wisdom based on the knowledge of the stars. For example, Teotihuacan, Stonehenge, Shija, Karnak, Chichen Itza, Dilo, Jaipur, Risco Caído and Sacred Mountains, or Talayots in Menorca, or only a few examples symbolizing this legacy, made up of an infinity of artistic, scientific, and ethnographic manifestations conserved at all latitudes. Furthermore, the night sky has inspired numerous great works of art, literature, poetry, and music across all human cultures, religions, and societies. The cultural and religious practices of many people, especially those in indigenous societies, rely on access to the night sky. Although for the moment, UNESCO hasn't so far declined to recognize the night sky itself in the context of the World Heritage Program, it has conferred World Heritage status on many monuments and sites associated with both historical astronomy activity or archaeoastronomy. Next one, please. Biodiversity and environmental value. The loss of quality of nocturnal sky caused by negative effects, next one please, of atmospheric emissions and of the increased intrusion of artificial lights and sky glow has become a serious threat for many species, disturbing their habits and habitats as well as the basic functions of ecosystems. Scientific evidence for the impact of light pollution in migratory birds, wilderness, fauna, sea turtles, oceanic species, and insects is striking because of the large-scale mortality that has occurred as a result of artificial night lighting, a phenomenon which is increasing worldwide, also because of the increased negative impact of the blue-rich LED. a technology that has been replacing the traditional electric discharge sources of illumination, disturbing data on light pollution effects on flora and phytoplankton are also being obtained. Dark sky oases offer the possibility of controlling and minimizing or even eliminating the artificial illumination into their territories. Consequently, they are literal refuges for wildlife under the stress of increasing human territorial intervention, including environmental light pollution. Next, please. The health and biodiversity. Since life formed on our planet, it has developed with a predictable circadian rhythms. Every life form has evolved in coordination with the day and night cycle, developing the circadian system, which on mammals is synchronized by a deep part of the brain, the suprachiasmatic nucleus of the hypothalamus, and several peripheral clocks, passing its temporal signal to the organism via melatonin, an hormone produced by the pineal gland that peaks at night with low levels during the day. Too much light can affect people's health by changing circadian rhythms. Thus, reducing the emission of artificial light may help to protect biodiversity and improve health conditions for the general population. Next slide, please. The tourist must be an instrument to mitigate the climate change, also an instrument for sustainability and for development. The astronomy is the transversal element for the whole humanity. It's the starting point of the science and in many cultures, and it's a natural worldwide resource every day of the year. Then the astro-tourism epitomizes the tendencies towards more meaningful tourist experience based on conservation of natural resources, knowledge and science, potentially enriching by the traveler and the host communities. Navigation, archaeoastronomy, paleontology, astrophotography, local gastronomy, etc., or some of the most attractive astro-tourist resources. Next one, please. To be leader in astro-tourism, it's necessary to innovate, diversify, and sophisticate the offer, personalizing in each destination and promoting the development, particularly involving public administrations, scientific institutions, starlight guidance monitors, local communities, and entrepreneur clusters. As a good example of good practices on astro-tourism, we have chosen La Palma Island. The world's first starlight reserve was acknowledged in 2012 as a starlight tourist destinations. It's also an UNESCO World Biosphere Reserve and hosts one of the most important astronomical observatories on the world, Roque de los Muchachos Observatory, and also was the first place in the world to apply a governmental sky law for astronomical observatories. We can enjoy in La Palma Island of stargazing activities, guided night trails, visits to the astrophysical observatories, etc. Some of the direct benefits of astrotourism are overnight stay and seasonalization. It is a very useful tool against depopulation and against decentralization of tourists in tourist areas. Next one. The line of actions will be monitoring the sky conditions in order to preserve the sky, training and consultancy. Also, the working group on scientific tourism, in particular, starting with the astro-tourism and led by the Starlight Foundation, has been constituted in the affiliate members meeting during the General Assembly of the United Nations World Tourist Organization held last year in St. Petersburg, Russia. The main purpose of this group will be to see the potential of this branch of enhanced tourism, as well as to create a forum where ideas and experience about combined science and tourism together are studied and contrasted, starting with the astro-tourism, reaching the sustainable development goals of the Agenda 2030. That's all. Thank you very much. And our colleague, John Herschel, will follow.
Thank you very much, Antonia. So I will continue for the next few minutes. Now, one of the main purposes of this workshop is to make recommendations to the UN committee called COPUOS. COPUOS is the Committee on the Peaceful Uses of Outer Space. And of course, if astronomers are to observe outer space, they have to be able to see the stars even from the ground. And so this whole conference is divided into 5 working groups, and it's just the Dark Sky Oases working group, which is presenting today, the other 4 in the subsequent days this week. So each working group is making recommendations to COPUOS, and the Dark Sky Oases working group has the following recommendations. Our recommendations are actually in 2 parts. The first part is how bright should the night sky be allowed to be in a dark sky oasis. Remember, a dark sky oasis is a place where the dark sky has some kind of regulation or protection. So our working group has used the IUCN, International Union for the Conservation of Nature, classification of the different types of dark sky place. And class 1 are the places with research astronomical observatories, professional observatories. And our recommendation is that the sky glow from artificial light at night should be no more than 10% of the naturally occurring airglow. You can measure this in millicandela per square meter, or perhaps a more useful unit is microcandela per square meter. And the microcandela is just 1,000 times smaller unit, so the numbers are a little bit larger. So for many years now, since 1980, the International Astronomical Union and the Committee on Illumination, International Committee on Illumination, have recommended that in these places with astronomical research observatories, the sky glow should contribute no more to sky brightness than 10% of the more than the airglow. Well, the airglow is approximately 240 microcandela per square meter. It does vary from place to place and from time to time, so it's not a fixed constant, but roughly it's 240. 10% more than that is 260, or if you prefer the units of stellar magnitudes per square arc second, that would mean greater than 21.7. Remember that the fainter or darker skies have larger numbers for magnitudes per square arc second. So our recommendation is for class 1, IUCN class 1, the value of the sky brightness should be 260 microcandela per square meter or less. These recommended values are simply aspirational goals. We don't intend them to be absolutely fixed, rigid limits which must never be transgressed. Some places are naturally darker than these limits. Some are brighter and probably struggle to reach these recommendations. The next type of dark sky place, the dark sky park, very often they are national parks in various countries. We suggest that 50% more than the natural airglow would be appropriate, about 360 microcandela per square meter or less, or in magnitudes per square arc second more than 21.4. And then we've got the dark sky heritage sites. We're recommending 2.75 times the natural airglow, about 660 microcandela per square meter or less. And then for the outreach sites, class 4, can we go back, please? Thank you. And the dark sky reserves, we will tolerate twice the airglow, or should be less than 480 microcandela per square meter. And then the dark sky communities, they're the more urban places, small towns or villages. We would tolerate 3 or 4 times the Airglow, 3 times for the more rural ones, in the semi-urban places 4 times. So those, that would give up to 1,000 microcandela per square meter. So those are our recommendations for how bright the sky should be allowed to get. And how do you achieve that? You achieve it by having good lighting. So let's look at the next set of recommendations. Next slide, please. So these are a little bit detailed and some places a little technical. And I think the best I can do is to just read these recommendations to COPUOS, the Committee on Peaceful Uses of Outer Space, so you can digest them and think about them. First of all, in all protected dark sky oases, the default condition should be no artificial light at all. That's the default. And if you absolutely need light, then you can go away from that default. In ecological reserves and similarly sensitive sites with little or no human presence at night, artificial light should not be used. But if it is used, it should be a narrow band amber LED. Now, LED is, of course, the light emitting diode. They're the latest technology. And there are various types of light emitting diode. The narrow band amber is the very latest technology. It has essentially no blue light at all. The shortest wavelength is about 540 nanometers from the narrowband amber. They're rather expensive, these narrowband amber LEDs, not deployed or used very much yet, but probably they will be. So it's the blue light, but less than 500 nanometers we want to avoid. So lighting should be strictly controlled and switched on only when it's needed. We need active controls of lighting only where and when it's needed. Now, a type of LED which is becoming more and more common are the phosphor converted amber LEDs, where the blue light peak that Costas Borusas talked about is greatly reduced and converted to longer wavelength yellow light. The phosphor converted amber LEDs have very little light, less than 500 nanometers wavelength. And our recommendation is that they should produce no more than 5% of the total spectral energy or power being emitted. And generally that requires LED lights with a color temperature of 2,200 Kelvin or less. So the color temperature is a fairly crude measure of the blue light content of any particular light source. So 2,200 Kelvin is a fairly sort of yellow-orange color of light, because the blue has largely been eliminated and limited to no more than 5%. Next, all exterior lights should only distribute light below the horizontal. If light goes up into the sky, it's probably not illuminating the scene or the area intended. And the upward light outward ratio should be no more than 0.5%. So that requires having luminaires which are mounted horizontally with a flat glass screen below the light source. A lot of street lights are tilted, and that's very harmful. It's just putting light into the sky, and that light is essentially not useful light at all. Can I have the next slide with more recommendations, please? So no development, that means no commercial development in or near highly ecologically sensitive sites should be permitted. So people can't build a hotel with flood lighting, for example, in a dark sky oasis. Monitoring of nighttime conditions in or near dark sky oases is encouraged through a combination of ground-based and remote sensing methods. So in any dark sky oasis, we have to measure how bright the night sky is with photometric methods, so we actually know if these brightness limits are being transgressed. And that requires active management of the natural nighttime darkness as a natural resource. That is encouraged. So if you have a dark sky place, you can't just say, okay, that's done, we can leave it now and just let it exist by itself. It requires people to be constantly checking that the lights are correctly installed and measuring the brightness of the night sky. And if those limits that we recommended for sky brightness are transgressed, if the thresholds are broken, then we need restoration plans to be implemented so that improvements in lighting can come about. So those are our recommendations for dark sky oases. And now I'm going to hand back to Kathy Neild, who is our chairperson or moderator for this session. And I think she will be introducing the questions and answers. Thank you very much, everyone.
Thank you, John. Thank you for all the other presenters this afternoon, this evening. Now we're going to open the floor to questions, as I mentioned before. If you have a question to ask, please use the chat. And please try and keep just questions into the chat so that we can collect the questions to pass on to the person who will be answering the question, who is Pedro Sanjuez. So we'll just give you a few minutes to regroup and perhaps start typing in your questions there. And I will pass things over to Pedro, who will be asking the questions as we move along. So thank you.
Okay, thank you, Catherine. And thank you for the presenters. And we have a huge amount of chat and discussion. And so it could be very difficult to condensate all questions, but we will try to do our best effort. Well, first of all, for Dr. Jon Earnshaw, there is a question about how will the sky brightness be determined for a certain place as it varies a lot. How one can find a characteristic value for a certain place.
So Pedro, that was a question for John, yes?
Yep, Jon.
Okay.
He's muted.
John, if you can unmute yourself, can you take care of this question?
I've unmuted myself. So how do we measure the sky brightness? Essentially, there are two ways of doing it. We can have a light meter on the ground and look up, generally at the zenith or some angle close to the zenith, straight up. Or sky brightness can be measured from space, and then it requires measuring the light leaving the Earth and doing fairly complicated modeling, as Fabio Falchi and his group in Italy have done. The easy way is simply to have a small handheld light meter, and in Canada, a company called Unihedron have made the sky quality meter, and a lot of people around the world are doing this. The sky brightness certainly can change with time on a short scale, as if people turn on bright lights, or on a long scale as urban developments expand and more houses and streets are constructed. So that's why we need to monitor the brightness continuously. So I mentioned the sky quality meter, that's widely used. There's also another sky meter which is often used called TESS. The TESS sky meter is in common use around the world. So I think having these standard measuring devices has been very useful to make a uniform type of measurement in many dark sky places.
Okay.
I hope that answers the question, probably enough.
And there is a related question. Are these recommendations aligned with any international standard or norms?
Well, probably I should pass that to Kathy Neild, because CIE, the International Commission on Illumination, has standards. I believe the European Union has some lighting standards they're trying to get all member countries to adhere to. The IDA has standards as well. So yes, there are various standards in different bodies. So we are making recommendations from this workshop to COPUOS, and I hope our recommendations are at least consistent with what other people are advocating.
So John, I think the best person to answer the technical question there is Kostas.
Yeah, I agree.
Kathy, maybe I can help to answer this question a little bit.
Certainly, Steve. If Kostas, yeah, I'll hand to you, Steve.
Yeah, go ahead, Stephen. I will take over.
Okay, so yeah, so in our TC 4-58, which is dealing with the light pollution measurement and also the dynamic and colorful evaluation assessment, okay, for the light pollution level. And we are slowly developing the standardization, okay, for the measurement as what is being asked, you know. And of course, in the division, we are in the division 4. And of course, in the this should be focusing on the measurement should be the work for the division 2. That's why we are discussing internally in the division 2 and the division 4 within the CIE to make sure that we have a standardization in the light pollution measurement. That includes the measurement methodology and also the procedure, calibration procedure, and also the uncertainty evaluation for the sky glow measurement, okay? And maybe Kostas, you want to add a little bit on this?
Yes, thanks, Steve. I completely agree with Steve that there is ongoing work on generally restriction of sources that actually produce sky glow or glare or obtrusive light. Regarding the general question, if there is an existing document or standard that specifies the sky glow or the limits, actually they're not such a document, but all relevant documents actually mandate how you have to illuminate, what kind of illuminance or luminance levels you have to use for streets or other places. And also there is the CIE 150 document, which actually limits the number of candelas or the luminous intensity that comes from buildings, from light sources towards users and so on. So the combination of all these documents actually tends to control the obtrusive light that actually generates sky glow. What is actually missing is a standardized document which calculates, states, or predicts the natural sky glow and the limits of different levels of areas in the sky glow.
Okay. And Kostas, we have another related question: is there countries taking these considerations or recommendations into account already?
To my knowledge, respectively of light pollution in general, there are several countries that have national or regional laws, but there is actually nothing to do with the sky glow itself. So I think that the question, the original question was if there is something about sky glow that is written in a document. So this is actually our goal, our future goal, to have methods for measuring, methods for modeling, and methods for monitoring sky glow in order to include such kind of limits inside, because the existing scale of magnitudes actually is so elastic, I have to say. So 0.1 in magnitude means a lot of variation in candelas per square meter for the sky glow. In addition, there is also a discussion about the directionality of sky glow. So it's completely different to measure in zenith, in 10 degrees of field of view or 20 degrees of field of view, and completely different to assess sky glow near the horizon. So everything shall include also spectral measurements and assessment in all wavelengths, not only the visible radiation, the photopic radiation, photopic vision or scotopic vision or whatever. It's the complete assessment, holistic assessment of the whole sky glow spatially and spectrally.
Okay, thank you. So we have another question. How do we agree on a measurement for light to create simple policies? Most people working in local authorities do not have the relevant background in lighting to understand or make educated decisions around lighting. Perhaps Kostis and Steve?
Yeah, if I understood correctly, we are discussing about the lack of experience or background, technical background for decision makers or lawmakers, how to prepare legislative actions against light pollution or against obtrusive light in general. Yeah, this is true in many cases, but I think that most legislative bodies, country or counties or what is actually the authority, have a lot of material to consider, like CIA documents or EN documents or IES documents. So I think that this is, in most cases, solved if they have specific documentation to consider. Otherwise, just a low background makes no sense for such kinds of legislation. Steve, okay. I don't know if you have an additional comment.
Our from the Starlight Foundation, if I able to participate, we are organizing a workshop for technicians and lighting technicians in different municipalities. We think it's quite important, the education, also with the people, the education in the school, but indication for professional, no many. And then I think this is quite important, the recommendations we are suggesting, because this must be the basis for this training. I think so.
Pedro, can I just make one brief observation? I think it's quite correct. I think the communication of this information at the right level, at the right time is really important. And as Antonia says, you know, her organization is running some workshops to hopefully train and share information, and organizations like the CIE, we ourselves have a workshop actually in November online on the calculation and measurement of obtrusive light, and also therefore for sky glow. So these types of opportunities to share the information are really valuable. And I think obviously as one of the recommendations even of this chapter or of this document in general is that, you know, there is adequate training, there's adequate dissemination of information and resources from the relevant bodies, whether that's the IGA, the IAU, the CIE, or any other body involved in this area, to make sure people are well informed and are doing things in the best practice way. Thank you.
Okay, for John Valentine, does anyone have an example of where major cities did the right thing in constraining light pollution? It seems to remember that San Diego protected the nearby observatories, but wonderful about places equivalent to London without adjacent scientific facilities.
I'm afraid to say that we do not have good examples of very large cities that have done the right thing as we would describe it. The cities that have a range of inhabitants, maybe from tens of thousands to perhaps 500,000. I'm in one right now, the city of Tucson, Arizona, which has a population of about 550,000. But our motivation to do the right thing is because we have a number of professional astronomical observatories in our vicinity, and their protection is important because they're an important contributor to our local economy. Most bigger cities will not have that. They don't have the incentive to protect their night skies that relates to economy or other concerns of residents. But we do believe that the practices and the policies that enable these protections in a city the size of a place like Tucson can be scaled up. There is no practical or technological barrier to doing that. And rather, I think the reason is that in the bigger cities, they mostly lack the political will to make the right decisions and to implement these kinds of practices and policies. So we do believe that the ideas that we're discussing here are applicable to municipality of any imaginable size. And it's the question is really about how do we convince the people who live in those large cities to undertake those efforts.
Okay, and also to you. Do the designations given through the IDA program seem to affect night sky brightness trends at participating sites?
That's an excellent question, and one that we ourselves are trying to find a better answer to. Right now, the best I can tell you is that we do not know. We don't have enough measurements of sky brightness properly geographically distributed from enough of the dark sky places to say with any certainty whether this system works. There's a little bit in the literature as well, rather than looking at sky brightness measurements from the ground, looking down from overhead with satellite remote sensing, and that also to date is inconclusive. We think there is a strong theoretical basis for tying these restrictions and better conservation practices to improvements in night sky quality, or at least maintaining the quality where it exists right now. But we just don't yet have enough data to make really robust conclusions.
Okay, thank you. And also to you and to Antonia, do IDA and Starlight Foundation designation increase tourism in the international dark sky places, and how to deal with the impact of tourism, which is part of the discussion in the chat?
Let me start with that, and then I will hand it over to Antonia to give her perspective. We certainly think that there is a connection between dark sky designation and astro-tourism and the revenue that comes along with it. We have a lot of anecdotes about that. We have a limited amount of empirical data that is supportive of that notion. It does depend very highly on the local circumstances, and in part how local governments implement policies and try to promote tourism and remove the barriers to that. But much like with the question of whether the dark sky places are effective in that regard, we simply don't have enough empirical data to answer that question. As to whether we can maintain darkness in places where there's a lot of visitation, that's also something of an open question. We think that by requiring the places that receive designation to be very rigorous in their own application of light, if they can work with the surrounding communities that are not necessarily part of the designated area, that the locals will understand that the ability to continue to draw tourism depends on keeping the lighting a certain way so as not to damage the resource. And there too, we have some limited results in some of the dark sky places where we have local success stories where people in municipalities beyond the dark sky place, but who are benefiting from the designation, seem to be doing the right thing in order to try to grow responsibly. And Antonia may have more to say about that.
Okay, thank you, Jo. Sure. Mainly the Starlight tourist destination even were created in order to protect this site, to help different towns and cities, but mainly rural areas, which are unpopulated areas with best sky conditions, in order to diversify the offer, and to promote activities related with this sustainable resource, which are the stars, in order to promote the development, the sustainable development of these local communities. For this reason, the most numerous part of our Starlight tourist destinations are rural areas, biosphere reserves, and many towns which are becoming more and more unpopulated. Then for that, I think the resource is a free, the sky is a free resource. Then we can obtain in different studies performing, for example, 2 years ago with Airbnb in many starlight sites and potential starlight or IDA sites. And we can see that the number of visitors that going to enjoy of stargazing is increasing from 90%, for example, in La Palma, where there is a flat at this moment because it has a very, and up to 350% in different sites. And we can see that in many of the small towns, for example, in Spain, with maybe a few hundred of people, the number of visitors per year is increased of order of 30,000 or 25,000 visitors. The idea is that the sustainable development could be linked with a measurement of sky protection and with an articulately management of the product. And then we can see that usually in this small village, we have increased the overnight stay, and then people reevaluate the natural resources, the ethnography, the gastronomy, etc. All that must be linked, joined to the sky in order to singularize the sky in every part of the country. And then in this end, we can see that we have growth about 3,000% last year in requested Starlight tourist certifications, mainly in Hispanoamerica, Costa Rica, Puerto Rico, in Mexico, in Argentina, in Colombia, in Chile, but also in Europe, in Africa. Now we are working, for example, in Botswana or in Pakistan, in order also to improve or promote the role of women in astronomy. Then I think this is a very nice product for the small communities and the indigenous societies also.
Thank you, Antonia. I have a general question. There is almost no effort in less developed countries to protect their night skies. It is not possible to make a proactive approach to those countries for protection of worldwide light pollution. It's a general question for both John, I think.
Well,
we're big. Oh, go ahead, John.
You answer that, John Barentine.
I would just briefly to answer that. I would say that that's something that's very concerning to us, but we also are very mindful about the fact that in a lot of the parts of the world in developing economies where there is a vast resource of natural darkness, but there's also a development pressure that threatens that resource, unlike at any time in history, that many of those places have been subject to a colonial history in their past. And we're very mindful about the notion of continuing that unfortunate past by trying to come in from the outside and essentially dictate the terms. So we feel that places that are in those circumstances really have to proactively make the decisions for themselves. They have to want there to be change. They have to want to protect the resource they have. Astro-tourism may be the key to that, but we think it's very important that decision to do something about the problem be left to them to make. And only once they have made that decision can we as experts come in and advise them, and that otherwise that we should not try to impose something on them if it is not wanted.
Okay, thank you.
I would make the point that developing countries are certainly not the worst polluters with light pollution. And it's the developed countries which probably transgress the worst. And it's the very big cities in North America, Western Europe, Eastern China, and Japan, which actually have the worst problem of light pollution. And that they are some of the most developed places in the world. So I would say one of the purposes of this workshop is to bring the attention of the United Nations to the problems of light pollution. And that is the way to get through to developing countries. So I think one of the motivations for this workshop is exactly that, to address the whole world and not just developed or developing countries, but everyone.
Okay, thank you. I have a general environmental question. Are there any good solutions to reduce light pollution generated by greenhouses? Perhaps John, to continue with this.
Was that John Barentine you were asking?
Yep.
Ed, just so I understand the question about, this is about residential housing, is that correct?
Well, the question is exactly, are there any good solution to reduce light pollution generated by greenhouses? It's perhaps
by greenhouses.
Yep.
Yes. We have been studying that question lately because that is a rising problem, at least here in North America, and it may be in other parts of the world. One way to do it is by not lighting greenhouses at night, but the operators generally don't like that because they would like to have 24-hour growing operations. There are commercially available solutions, at least here in North America, that involve retractable window coverings on greenhouses that can be closed at night to retain both light and heat, which is something that's of value to the operators. As far as the regulatory piece goes, I think it will mainly happen as a result of concern over what we call light trespass, which is the tendency of light emitted on one property to cross a boundary onto another where it is generally not wanted. And so there are legal mechanisms to deal with that problem, but we would ideally like to stop the problem before it starts by ensuring that the operators of greenhouses are keeping the light on their property and keeping it inside the greenhouse where the plants can use it and not releasing it to the night sky. The shortcoming of that is that approaches dealing with light trespass generally only put the shielding on the sides of the building, because light that escapes through the roof or the ceiling of the building is not considered obtrusive. And we really do need to impress upon the regulators that you must also cover up the ceiling panels in order to prevent escape of light into the night sky.
And perhaps a related question for Costis, are outdoor lighting policies effective at reducing light pollution and preserving dark sky oases?
Can you please repeat the question for?
Yep. Are outdoor lighting policies effective in reducing light pollution and preserving dark sky oases? Perhaps it's a question coming back to our main topic of today.
Mm-hmm. I think that this is a question that John Barentine can actually answer. It's strictly related to dark sky oasis, but just a point of view from my side, if someone can follow some existing regulation of good lighting design, appropriate equipment and lighting controls, can at least mitigate what is going to happen during night if you just leave everything on. This is the first one. The second one is actually if there is a local law or a local ordinance that states that this area should be protected and all the surrounding of 100 kilometers to 100 kilometers or less should follow these rules. So it's strictly dependent to the county, area, municipality, or whatever. So please, John, if you have additional information.
I would say that this relates to the question earlier about whether we know if the preservation of dark sky oases results in measurable changes somehow. Can we detect in the field, is the sky getting darker, brighter, is it staying the same? And I said that we don't have enough data yet to be able to answer that question. And I think the same answer applies here, is that there aren't enough dark sky oases in enough different kinds of jurisdictions with enough firsthand data for us to be able to make a very strong conclusion about that. We think on a very local level, if you protect a national park or a nature reserve or something like that, and you have light sources that are inside or nearby those places, that we can effectively deal with that light. And we're not seeing the brightness of the night sky over the dark sky oases necessarily drifting in a bad direction. We think those policies are effective. What we don't have any control over right now is the influence of a distant city on the horizon. So if you're in a protected national park, for example, and the national capital is 300 kilometers away and yields a very bright light dome on your horizon, there are inter-jurisdictional problems in trying to do something about that. The people who live in the big city probably aren't concerned about the impact of their light on the protected place. And that's a very acute need in this world of dealing with lighting policy, is understanding that the light that's emitted in a populated place does not stay there. It can travel many hundreds of kilometers, and it can yield an impact on the ecology and the night sky in a place that's very distant. So right now, I think that's one of the most important shortcomings of the policy regime that exists, and one that in the next decade that we will very definitely need to take on more directly.
Okay, thank you.
Can I make a comment, Pedro?
Yep.
My comment is based on our experience of our dark sky place in the centre of New Zealand's South Island, the Aoraki Mackenzie Dark Sky Reserve. There are two issues. We have a lighting ordinance in the local government, but the policing of that ordinance has always been a problem. And people will shine lights into the sky at their homes, and it's very hard to make them comply with the ordinance, because we have to lodge a complaint with our local government, and they then have to take action. So that's the first issue in getting compliance with the regulations. And the second is, I think to really make a difference, you've got to have very good public education. So our Dark Sky Reserve has a board, and our board is very actively involved with public outreach. So the whole community is aware that they are living in a dark sky reserve. And once people are aware, then they're more likely to comply with the lighting ordinance. So public education is a major activity we undertake. Thanks, Pedro.
Pedro?
I have to check a little bit because we have some other questions regarding Corpus' role. And one of them is, do you think that Corpus is the right forum to promote limitation of light pollution? So that's for Natalie, please.
Thank you for the question. I don't think we need to get into legal detail right now. I see there's been a debate on the chat. Suffice to say that this event has actually been specifically requested by Corpus. And you will see throughout the weeks that at the end, there's many different aspects to light pollution, and then it has a direct effect on the astronomical observatories. You'll see tomorrow it also has a direct effect on human health and impact on the rest of nature as well. So there are many angles to the issue, and then you will see more about this by the end of the week. Thank you.
Well, Catherine, thank you very much for all of you. And Catherine, please, to continue, because we have more options to receive questions and comments.
Indeed, I think people can still send in comments, as in Natalie's wrap up. She will tell people how they can get access to the documents and send in more comments. Is that correct, Natalie?
Yes, indeed, that's correct. So you will be able to keep sending us questions or most of all comments on the recommendation until Friday next week. Now, I actually saw a lot of interesting discussion in the chat about people's personal experience of the night sky. So do you think, like, as an advocacy measure, would it really make a difference if people who, for instance, live in cities and who have only seen the skies from the perspective of a city, do you see in your experience that then it really makes a difference when people can experience it by themselves? I'm just asking those of our speakers who are directly involved in managing dark sky oasis. What do you think?
John, Antonia? Pedro?
Antonia can answer.
Would be happy to answer all these questions. We are open if there is some possibility to retrieve all these questions. I can see there are many questions regarding educational activities. I think that's quite important. I think there are 3 great pillars in this issue, which are the education, the formation, and the public outreach. And regarding also I think there is somebody asking about the primary school children. This is many times very lost, forbidden collective. And then I think more and more there is an increased a number of educational pollution activities performed by different organizations and foundations and agencies, for example, NASA, or even the National Geographic, or many other organizations have or local communities organize a workshop in the Days of Science for children in particular. Also, for the Starlight Foundation, we have published recently a few multimedia video addresses to the children in order to focus and to enhance the importance of protecting the night sky. And then we invite you to visit our webpage and to call us to the Starlight and to provide all this information. I think it would be very important from maybe this working group to compile all these activities also of educational activities for online pollution, for these local communities, for this dark sky oasis. Maybe that could be, I don't know, what do you think, one of our future works or issue not to do.
Thanks, Antonio. Pedro, John, do you have any other comments? I think Antonio is quite right. Education and communication about the matters that we've discussed here and in the other working groups that are coming up today is paramount to making any change which is effective and also helpful, both on the actual need for lighting where it's needed in many ways and many aspects in life, and where it's probably not needed in the manner where it is perhaps over deployed. Due to, I think, people's keenness to use a new technology without thinking about the impact of using that technology. So with that, I'll just pass back to Natalie. I think we're at the end of this workshop today, so I'll just pass back to Natalie for her some concluding remarks. Thank you, Natalie.
Well, thank you very much, Kathy. And so before we close, I just wanted to remind everybody how to access the report, how to send off comments. So I'm just looking at whether Kathy has a way to put the slides back up. I think it was slide number 2 when we started today. So we actually had a lot of people joining us today. I mean, we had about 380 people joining at maximum. Again, my apologies for those who struggled to connect once we pass the 300 mark. That will not happen tomorrow. We'll make sure we don't have the issue. And thank you for being persistent and connecting again. So everything we talked about today, you'll find this in the report for the Dark Sky Oasis. You can download it from the link that you can see on the screen. And should you have any comments on our recommendation, you are very welcome to send us those comments with this link where we will just gather them all and consider them for the next update. So as you heard at the beginning of the event today, this is a process. We're having the workshop right now, but we're working towards preparing an event next year. You will hear more about this by Friday, and we are very much open for discussion, suggestions, and we are very thankful that we have such a huge attendance today. Finally, the event today was recorded, and we're going to make the video available so the people who unfortunately missed the beginning will be able to watch the beginning on video. So thank you very much again. And tomorrow, we will be looking at the effect of light on the bioenvironment. We touched a few of those topics today already, but you're going to see this in much more detail tomorrow. So I just invite you all to please reconnect tomorrow, same time here on Zoom, and we will talk about the bioenvironment. In the meantime, have a very nice afternoon, very nice evening, good night, and see you tomorrow. Thank you.
Thank you, Natalie.